Moving on to our next and last chapter, we're going to be talking about how to use Maltego in order to counter disinformation and how Maltego can be used by journalists. Maltego is a tool that can be used by journalists for data mining and analysis. It can be used to gather information about people, organizations, and relationships between them and identify patterns and connections. For example, a journalist could use Maltego to analyze social media data to uncover connections between political figures or to map out the structure of a criminal organization. Additionally, it can be used to monitor websites and social media accounts to identify potential leads or sources. Maltego can be used to help identify and track disinformation campaigns by analyzing data from various sources, such as social media platforms, news websites, and online forums. For example, it could be used to identify the individuals or organizations behind the disinformation campaign by analyzing the social media accounts and websites associated with the campaign. Moreover, Maltego can be used to map out the relationships between different accounts and websites, which can help identify patterns and connections that indicate a coordinated campaign. Maltego can help journalists and researchers better understand the scope and nature of a disinformation campaign and potentially provide leads for further investigation. One pattern of use would be as follows. The journalist receives a tip about a disinformation campaign targeting a political candidate. The journalist uses Maltego to gather data from social media platforms. The journalist uses Maltego to analyze the data gathered. The journalist uses Maltego to map the relationship between accounts and websites. The journalist uses this information to identify the individuals behind the campaign. The journalist uses the information found to identify potential leads for further research. One benefit of Maltego is that it incorporates several tools in one place, making it easy for journalists to focus on only one dashboard and immediately correlate newly discovered bits of information with its graphs. Among others, it helps disinformation dismantling by allowing research the network connections behind disinformation campaigns, research visual ties such as images or memes related with disinformation, research social media activity with extension. Before starting to use Maltego, it's important to have a clear idea of the investigation or analysis you want to conduct. Here are a few things to consider before getting started. Establish what you want to achieve with Maltego. Identify the data sources you want to utilize for your analysis. The interface is relatively easy to use. It is essential to understand the graph-based data visualization of Maltego. Paterva, the company behind Maltego, provides extensive documentation on the tool. It is important to be aware of the legal and ethical considerations when using this tool. Now let's talk about the Maltego interface and terminology. The Maltego interface has several components, each of which play a significant role. Understanding these components is important and will allow you to effectively achieve your goals. The Transform Hub. This is where you can access and run the various transforms that are available in Maltego. Transforms are scripts that can be used to extract data from various sources and create entities in the graph. The Transformation Hub is a data marketplace that allows clients to merge and combine data and transforms from multiple sources. These transforms are developed by Maltego clients like Whois XML API. In order to use them, they usually require an API for authentication. The Graph View. This is where the data is displayed in a graph format, showing the relationships and connections between entities. The graph view is interactive and allows you to zoom in and out, pan, and select entities. The Entity Palette. This is where all the different types of entities that can be created in Maltego are displayed. You can drag and drop entities from the palette onto the graph to create new nodes. The Case File. This is where all of the data that has been collected and analyzed in a case is stored. You can save and open case files and also share them with other users. The Machine Room. This is where you can access and run the various machines that are available in Maltego. Machines are pre-configured sets of transforms that can be used to perform specific types of analysis, such as identifying social media influencers or tracking a specific hashtag. The Status Bar. This displays the status of the transforms that are running and also shows the numbers of entities that are currently on the graph. The Menus and Toolbars. This contains various options, such as saving and opening files, editing the graph, and accessing the help documentation. The Transforms Results. This is where the results of the transform are displayed, and you can see the new entities and relationships that were created by the transform. The sidebar. This allows you to filter, sort, and view the properties of the selected entity. Entities represent a type of information such as the name of a person, the URL of a website, the IP address of a resource, an email address, or a phone number. Investigations and transforms start with at least one entity. All entities are located in the left side of the Maltego desktop client. Some entities in Maltego include IPv4 address, IPQS tag, DNS name, netblock, location, website, URL, image, person, domain, NS record, MX record. The process of extracting new information from an existing piece of information is called a transform. The process is called as such since it indicates that some data is being transformed to some new information not previously known. Transforms are grouped in sets and differ based on the entity. The default set of transforms is the standard transforms group. Machines are macros written in the Maltego scripting language that automate the process of running transforms. Simply put, if a sequence of transforms is commonly executed, a macro can be written to automate that process. Machines like Footprint 1 and Footprint 2 come pre-installed. These macros run the set of transforms commonly run to create a footprint of the target domain. Now we're going to take a look at how to download and set up Maltego. To download Maltego, go to www.maltego.com/downloads. In Windows environments, after downloading the installer, navigate to the folder where it is located and double-click to run it. Then follow the steps of the wizard to complete installation. Once the installation is complete, open Maltego from the Start menu or by double-clicking on the shortcut icon on your desktop. On Mac, open the installer and drag the Maltego icon to the Applications folder. Once the installation is complete, open Maltego from the Applications folder or by searching it in the Spotlight. When Maltego opens, you will be prompted to enter your email address and choose a license. You can choose a free community license or a paid commercial license depending on your needs. The options offered are Maltego 1, Maltego XL, Maltego Classic, Maltego CE, and Casefile. For most of these challenges, using Maltego Community Edition will be sufficient. Note that the version can be changed at any time. To use Maltego CE, first create a community account. Use the email address and password set up in the website to log into the desktop application. Now it's time to see how to install transforms. Click the Transform Hub button under the Transforms tab and you will be directed to the Transform Hub page that displays all transforms. The Transform Hub allows you to easily install transforms created by different data providers. To install a new Transform Hub item, simply click the Install button found when the mouse is over the item. The WhoisXML API transforms will be needed for several of the CTF challenges. With these transforms, you can look up live and historical Whois records for domain names and IP addresses and conduct reverse Whois searches by looking for phrases or text within Whois records and more. After clicking on Install, an installation confirmation dialog will appear. And then, after clicking Yes, another dialog box will appear for the required fields. To obtain a WhoisX API key, you need to proceed to whois.whoisxmlapi.com/signup and create a free account. Verify the account from your email address and proceed to login. On the first page in the top right corner, click on your username and select My Products from the menu bar, and then your API key will be displayed. Copy the API key, get back to the Maltego installation window and paste your API there. Once the item has finished installing, an installation summary page will appear listing all installed items. To complete the setup, the Wayback Machine transform set will also have to be installed. Wayback Machine allows users to browse snapshots and archived content of billions of websites that can go back years and decades. The Wayback Machine is a top-notch OSINT tool for web investigations. You can reveal deleted pages, hidden files, changed content, historical connections, and more. Following the same guidelines as for the WhoisXML installation, click on the Transform Hub button under the Transforms tab and in the search bar, search for the Wayback Machine to find the item. Clicking Install will take you through the installation process. When it's finished, an installation summary page will appear, listing all installed items. Now, we're going to be taking a look at case scenario 1, which is analyzing disinformation networks. Maltego can help uncover the evidence of a disinformation campaign by using digital clues such as IP addresses or URLs. It can gather this information and connect it together to show a clear picture of how a disinformation campaign is spread and who might be responsible for it. This visualization allows for a deeper understanding of the campaign's online infrastructure. This case scenario maps out an Iranian network infrastructure identified by the Department of Justice as a source of disinformation. The mapping will be carried out using the WhoisXML API and Maltego standard transforms. The investigation will start from 3 domain names that the Department of Justice seized: presstv.com, lualuatv.com, and almazira.net. The investigation started with 3 domain entities being added to the graph. The domain name of each one was inserted. The initial to Whois records transform shows that data that could be used to identify the domain owners is limited. There is no name, email, or phone number. Another way to find information about who registered the website or IP address is to look at records from a specific period of time. This can be done using a tool called Transform Manager, where you can set a time frame and then check the records for all of the domains within the time frame. This is known as to historical Whois records transform. Now we can find out who registered the website or IP address by looking at records from a specific period of time. We use a tool called Transform Manager to find this information. We select all the records and run some special tools called to registrant name, to registrant organization, and to registrant email transforms. These tools will give us the name, organization, and the email address of the person who registered the website or IP address. This information can be used to find more websites or IP addresses that have been registered by the same person or organization. We are going to remove some information that is not useful for our investigation. We will remove any names of people or organizations that contain the words privacy or private in them, and any organization that contains the words privacy, private, hosting, or CDN. This is because this information will not give us any useful results. After that, we will use a tool called toDomains and IP addresses, which is a reverse Whois search transform on the remaining information. This tool will help us find new websites or IP addresses that are connected to the people and organizations behind the disinformation network. This will give us a more complete picture of the network. Now we are going to use a tool called toNameServers transform on the information we have collected. This tool will help us find the servers that are used to connect a website to the internet. Some organizations use a special type of hosting called Content Delivery Network to host their servers, while others use their own servers. We will remove any servers that are hosted by a CDN so that we can find new websites or IP addresses that are connected to the network we are investigating. We will also use a tool called toDomains and IP addresses transform to find these new connections. We will also use a tool called toDNSNameMX transform to find the servers that are used for sending emails. We will then use toDomains transforms to find new websites or IP addresses that are connected to these email servers. All of the new websites or IP addresses we find will be connected to the original network we are investigating. To keep track of the results, we will mark any new websites or IP addresses in green. We will also mark any remaining information in purple on the graph. We can use the information from websites that are connected to the domains we have found to find more information by using a tool called toWebsiteUsingDomain on the domain entities. Sometimes, not all the websites give us information, which could mean they are not being used. If needed, we can check how the websites used to look in the past to get more information by using a tool called Wayback Machine Transforms. We will now look at how different websites are connected to each other from a technical point of view. We will focus on finding codes that connect to the websites. We start by using a tool toRelationships on the website entities and remove any information that points to an IP address. Then we use a tool called toWebsites on the remaining information, and finally we use a tool called toDomains on the information from the previous step. This allows us to find more domains that are connected to the one we started with. To focus on the domains, we add all domain entities to a new graph and mark entities that need more investigation in yellow because we are not certain they are related to the original 3 domains. We can use the list view arranged by entity name to see that multiple domains are used across different top-level domains. This could be a tactic used by outlets to reach different audiences or avoid sanctions. After running the two-domain transform on the domain entities, quite a few valid domains that can be found across new top-level domains were listed. We bookmark the remaining unbookmarked domain entities to signal that at the moment it cannot be proven that these entities are owned by the same group we are investigating. After pasting all domain entities onto the original graph and merging them, we see that from the 3 original domains with which the investigation started, 300 others spawned, quite a few of them ending in .com and .net. We can conclude that all of these domains are allegedly part of the network of disinformation used by Iran, which demonstrates that it probably suffered a great blow when the seizure took place. Now let's take a look at how Maltego can be used to track fake news. Fake news refers to the dissemination of false information or hoaxes presented as if they were real news. It can be spread through traditional news media as well as through social media and online platforms. One way to spot fake news is to check the source of the information. If the source is unreliable or has a history of publishing false information, it is more likely that the information is false. It is important to be skeptical and to do your own research to verify the accuracy of news stories. Oftentimes, figuring out who is behind the campaign can help clear out any skepticism about the article or its intent. Maltego could help in pinpointing this information in several ways. We are going to discuss one scenario in which you found a news article that seemed doubtful when scrolling social media. This image explains a possible methodology of discovering the origins of the article. You could start 2 parallel searches, one focused on the keyword or headline and the other targeting the website URL. Starting with a general search will help understand the spread of the information. In Maltego, drag a phrase entity to the dashboard and paste it in a key phrase from the article. On it, run to the website transform to get a graph of website and news sites that reported the case. If you want to add several phrases, just drag more entities on the graph. The same applies if you want to search if the article has gained international traction. For each language you want to investigate, add a phrase entity with a translated keyword. On all results shown, run to the URLs transform to get the URLs of all of the websites found. The other parallel investigating path would be to insert the article URL in an URL entity. A good practice is to bookmark the URL so that you can refer back to it during the process as the graph expands. Run the to-website entity to extract the name of the website hosting the article. You might already get a connection between this website and one of the results shown in the phase 1.1. Before moving on, sort through the URLs and check if all are applicable to your case. As the number of artifacts will continue to increase, filtering only relevant content will help you stay focused on the key ones. Try to get infrastructure information by running the to IP address transform on the website entity extracted in phase 1.2. On the IP address entity, run the to website using IP transform to list any other websites hosted on the same IP address. This might create a connection to one of the websites or URLs found in phase 1.1. This step aims to link websites with similar ideologies or that unwillingly spread misinformation. Go back to the target URL and run the links to transform. Showing all links might help understand underlying connections and map out the network. Note that this transform might return a high number of results. One way to group them is to run the to website transform on all the resulting URLs. This way, URLs belonging to the same website will be grouped together. It is again recommended to filter out links not related to the investigation. For example, a website might contain marketing links or links to other unrelated information. There is another transform that will obtain external links, the mirror, external links found transform. Run it on the target URL as well as check if anything new is added to the graph. Extracting images might help understand whether other websites using the same images are reporting the same story. To get the images, go to the target URL and run the to images transform. Again, note that there might be results not associated with the investigation. Go to the website entity gained in phase 1.2 and run the to relationships transform to find tracking codes such as Google Analytics and the like. Tracking codes are code snippets that send information from the website to other external sites. Select the results of the previous transform and run the to matches transform. Look at the results shown and see if any new website appears. Tracking codes are unique per user organization, therefore, having any other website pop up might indicate that they're owned by the same user or the code had been hijacked illegally. Scan the images from phase 4 and select some that you believe are unique to the article and run the search for pages linking to similar images transform. If the number of URLs returned is too high, run the to-website transform to group them. Pay attention to links that redirect to social media or blogs, especially if these resources are politically infused. If the article tries to undermine an organization, group, NGO, product, or alike, check to see if you can find links to any competitor indicating a smearing campaign. Similar IP addresses or tracking numbers will help you build a profile on the website spreading the information. If you find links to blogs, continue with the transforms to possibly find who owns the sites. For social media, use transforms such as Pipel, Shadow Dragon, or social links to see how the story propagated through the groups or users. The preceding exercise showcases how to complete the Maltego CTF and help you achieve a deeper technical understanding of publicly available resources that you can use during an investigation. We strongly suggest you first try it by yourself and then you can come back to the video to evaluate your progress. You can do so by visiting the www.maltegoctf.org. Anyways, without further ado, I will leave you to my colleague Riyad, who will explain the Maltego CTF exercise.
In this walkthrough, we will go step by step through the Maltego CDF, acquiring all the flags and submitting them to the flags platform in flag.maltegocdf.com. The student will be provided with only one piece of information, the maltegocdf.com domain, which will be the starting point. The flags platform will also act as a guide containing hints and descriptions to help find the flags. First, place the domain entity on the whiteboard. Next, put the domain on the domain entity. In our case, it's maltegocdf.com. Once that is done, we can go right-click on it and run transforms. Now the one we are going to run is the NS records to DNS name transform. The return result will be two NS record entities, pointing to Cloudflare name servers. This is an indicator that the website is shielded by Cloudflare. The first flag is the security provider used for the server, in this case being Cloudflare. Submit Cloudflare as the flag. The second flag is found by discovering the Cloudflare IP range of the server. Right-click on one of the name servers and run the result to IP set of transforms. Proceed with the same step for the other name server. Submit the total number of assigned IPs as a flag. The next flag is the real IP address of the server, which means that Cloudflare should get bypassed to discover this IP. To obtain this flag, extract the DNS MX records, which will disclose the IP. Go back to maltegocdf.com, the domain entity, and right-click on it. Go to Standard Transforms, select DNS from Domain, and then click on to DNS name MX. Run the result to IP transform as shown in the video to get the mail server's IP address. This IP address will be the flag. Now all you need to do is submit the IP address as in the flag format that is shown in the description. The other challenge requires finding the domain name associated with the IP that was just found. This is done by doing a DNS lookup. Let's go back to Maltego. Right-click on the IP address entity and expand the standard transforms set. Click on DNS from IP and choose the to DNS name reverse DNS. The output will show us that the server is being hosted on AWS as an EC2 instance. EC2 is the flag in this case for this challenge. So let's submit it. This will finish this challenge. What is the IP range of this IP? For this, go back to Maltego and right-click on the IP. Then, in the search bar of transforms, type to-net block and take a look at the options. The to-net block using routing info transform makes use of the Border Gateway Protocol (BGP) data. This will be the one that will disclose the full IP range. This IP range is the flag for this challenge, so submit it. After the IP range disclosure, you can now also find the server's IP location, which happens to be the next challenge. Go to Maltego, and let's find the IP range entity that we just found. Right-click on it, and on the transforms, search for the to-location transform. The challenge stated that only the state is the flag. After running the transform, we can see that the IP is located on Oregon State. So let's submit Oregon as a flag. The last challenge in infrastructure mapping is finding the subdomains of our main domain, which is maltegocdf.com. Go back to Maltego and locate the main domain entity that was placed in the beginning. Right-click on it and search for to-DNS name using name schema transform. The transform will find three subdomains: blog, www, and mail. The blog subdomain seems like an interesting find. Be sure to check it out. You will get back to it later on the CDF. Now that we've found the subdomains, we can see that the total number is 3. So let's submit 3 as the flag. The first part is done, but this is only the beginning. The next section of challenges is website enumeration. By taking a look at the first challenge, looks like a flag is hidden in one of the images in the main website. With Maltego transforms, you can extract all the images on the website and look for the flag. First, go to the domain entity. Right-click on it and run the to-website transform. Then, double-click on the website entity to check its information and click on the Properties tab. Notice that no protocol, HTTP or HTTPS, is added on the website URL. Let's set the port to 443 and also add HTTPS before the URL. The URL entity has a set of web transforms associated with it and allows for more website information gathering. Right-click on the website entity and search for two URLs within Properties Transform. This will generate a URL entity from the website. Now the main step was to pull the images from this URL. To do that, use the two images found on the web page transform. Search for two images and run the transform. We can see that a lot of images get extracted from the page. Now, all you need to do is analyze the output. One of the URLs has a flag hidden in it. Find it, grab the flag after finding it, and submit it. The next challenge is to find the directories of the domain. To extract all links from the website, we can use Maltego transforms. Now, we have the URL entity. Use the two links found on web page transforms that are located in the same set as the two images transform. The output will show us multiple links of the URL. There might be false positives, but one of them is the actual directory that the flag is. You can go and visit each of the directories and see what output you get or what page is it. But the one we are looking for is the /research.html page. Go in a browser and visit the page. So we can go to the flag platform and submit /research.html as the directory that is the flag. Once the website enumeration section is finished, proceed with Wayback Machine challenges. The first challenge is stating that a maltegocdf.com/research snapshot exists, leading to a hidden document that was forgotten on the server. Grab a URL entity and place it on the whiteboard. Click on it and put the URL. In this case, the /research.html URL. Now, right-click on the entity and run the Wayback Transforms. The transform will get back with two different snapshots. We want to visit the last snapshot. Put the snapshot side by side with the current version of the page. A section has a different title. The current one is named Running a Transform, and the snapshot is named Macros. The challenge is also letting us know that every title has a PDF file named to it, so it's suggesting that macros might have a hidden PDF file on it. Now, if we press and read more, it looks like every section leads to a PDF file. The PDF file seems to also have the same name as the title. Going back to the snapshot, the section that is different is named macros, meaning that the server might have a macros.pdf file. On the URL bar, change the PDF file name to macros. And indeed, the macros.pdf file exists on the server, so we can submit the macros.pdf file name as the flag. So go back to flags and submit the flag. The next challenge is related to a way back snapshot with the main domain. Also, the title does give it out that we have to use inspect element to actually find the flag in this domain, or in this snapshot to be more correct. So let's put a URL entity on the Maltego whiteboard. And then use the wayback machine transforms the same way that were used on the earlier URL. The first link shows an image, and the three following links are CSS files. The last snapshot seems like an early version of the website and might contain some interesting information. Right-click on the website, and on the menu that pops up, select Inspect Element. Expand all HTML elements and see if you can find a flag. And after a while, we can see that the flag is actually on the HTML elements of the website, so we can submit the flag on the flags platform. Now, you will need to get back to the hidden document we found earlier to proceed. Maltego is able to extract all kinds of information from a document. So the next flag is the author's name of the macros.pdf document. In Maltego, search for the document entity and place it on the whiteboard. Then, just run all the transforms and see what Maltego finds. Right out the bat, locations and emails are extracted from the document. But there is a person's email specifically, and that person's name is a flag. Lauras Libini. The other flag is somewhere in one of the socials of Lauras. To find them, first create an alias with the same username as the email. So copy your email username and place it on the alias. Right-click on the entity and search for ToSocials transforms. some different platforms pop up, but the one that might interest us is the Medium one. Visit the Medium account. Giving it a brief read, Laras has shared her Facebook profile page. So let's go and visit her page. After locating Laura's Facebook profile page, we can see that the flag is located in her bio. Grab it and submit it at the flag platform. The next section of challenges contains VirusTotal. Now the challenge that we are looking at, it's telling us to go back to blog.maltegocdf.com. Now if we go into it, we can see Glitch in the Matrix has posted We'll allow that, and let's see what the file is about. So the file's name is transform.tar. And the challenge was asking for the file's name, so we can submit it as a flag. Let's go to the flag platform and submit the file name. The next challenge is letting us know that the server has been compromised by a file. So we have to scan the file that we just downloaded to see and prove that the file is the one that has compromised the server. To do that, first unzip the file and generate the SHA-256 hash value of the file. One of the VirusTotal transforms works by comparing hashes of suspicious files with hashes of known malware kept in a VirusTotal database. If there is a match, the transform shows a detailed report on that file, stating any potential risks or malicious characteristics that it contains. Drag a hash entity on the whiteboard. Right-click on the hash entity and search for VirusTotal transforms, and then run it. VirusTotal will get back with the result. And we can see that the file that it recognized is called c99.php. In the detail view, we can go and visit the link of the VirusTotal. In here, you can see that the file is actually malicious and contains a backdoor. C99 is a known PHP backdoor that was used in WordPress as a plugin. So this proves us that the file was the one that compromised the server. So we can go back to the flags and submit c99.php as a flag. After finishing the last challenge, a new challenge will be open to you, called Repo, suggesting that Glitch in the Matrix has a GitHub account, and some of his repos proves that he is the attacker. To find the GitHub account of Glitch in the Matrix, use the same method as Laura's Libini by using aliases. In the alias, copy the username that was shown in the challenge description and paste it on the alias. And by running the toSocialLinks transform, we will see that GitHub will get extracted and popped up. When the GitHub gets extracted, go and visit the page. On the first look, we can see that this is the real profile of Glitch in the Matrix. Take a look at the profile and take notes. There's a lot of information that can be useful on the next challenges. We can see two repos here, so let's visit one. The first one, we can see there is a c99.php file in here, proving us that Glitch in the Matrix has uploaded the same file on the server that was compromised. If we go back, there's another repo. It is a README file, and is an introduction for Glitch in the Matrix. And in the first look, you can see that Glitch in the Matrix has the skills to cause the damage. There's a Facebook profile linked on the bio. check the Facebook profile of Glitch in the Matrix. You will have to be logged in to view the Glitch in the Matrix Facebook profile. So go in an account and then visit the profile again. You will now be able to see each of Glitch in the Matrix posts, because they are available to the public. There's a lot of interesting information here, but the one we are going to focus is the last post, which seems odd. It's from 2014. You want to go and look at the shares, see who shared the post. A new user identity will be shown to you, named Gabriel Estrada. Visit its profile. Since we found the suspicious repo, submit it as a flag. A new challenge pops up. One main thing is the location of Gabriel Estrada. We can see the location is the same as Glitch in the Matrix on his Facebook profile and on his GitHub account, giving us a clue that this might be the same person. There's some anger post as well. You can see that Gabriel was fired from Maltego CDF. The anger was the motive to hack the website. So this is the main suspect that you have for Glitch in the Matrix. Go ahead and submit the flag by the Gabriel Estrada name. The new challenge that pops up is to confirm that Gabriel Estrada is behind this. To do this, on the description of the challenge, we have some clues. The blue and the about sign. The blue on this challenge is hinting that the information that the challenge is asking is found on Skype. On the whiteboard, you can place an alias for Gabriel Estrada that will help you search him. For this challenge, we will have to install a new transform called Social Links. To do that, go to Transform Hub and search for Social Links and install the CE version. After the installation is finished, go and proceed and run the Social Links CE transform on the alias of Gabriel Estrada. And right off the bat, we can see an account related to Gabriel Estrada that has the same profile picture. This account will contain the about info that you need for the flag. Double click on it and go to Properties, and the About section will contain the flag, which is a saying that correlates Gabriel to Glitch in the Matrix. This will indefinitely confirm that Gabriel was behind this and is indeed Glitch in the Matrix. So submit the flag. Now, after this section is finished, we will continue with the last section of challenges, containing local transforms. One of Gabriel's shares was a Medium blog post of one of his former colleagues. The same post was shared by Larry's on her Facebook profile. Go ahead and read the shared article. Who is its author and what is this article about? After reading the article, you might want to know more about this person named Arthur. Arthur seems to have quite a story. He found out that he was adopted and is now trying to find out more about his past. The article mentions a website that contains images of people who share the same background as him. He is in the process of developing a custom transform that compares his current image with the images of the lost children to check if any match in hopes he finds his childhood name. This yet to be finished transform is uploaded to his GitHub account, which you can find from his Medium. try to complete the transform and find a piece of Arthur's past. In this challenge, you will have to complete the code with Python from the GitHub account. We can also see the mentioned database of the lost children photo in his GitHub account, so we can get the photos there. After the Python file is assembled and ready, be sure to also have the requirements file that is in Arthur's GitHub. Install the required modules and libraries by using pip. After everything is already installed, run the Maltego trx command, which will create the Maltego transform environment. These steps are all detailed on the PDF walkthrough as well, so be sure to check it out. After that is done, move the Python code to the transforms directory. After the setup is complete, in Maltego, go to New Local Transforms. This is the place where you can import local transforms. Set a display name for your transform and a description. Also, be sure to select images as an input entity type and leave transform set to none. Next, you will have to set up a command line, which will tell Maltego how to run your transform. Set your command at user bin python 3, which means that we are going to be using Python. And the next fields, just follow the screen as well. Also in directory, be sure to put the same directory where your file is. In this case, the file is Maltego CDF, local transforms, and AI image comparison. This will install our local transform and it is ready to run. Okay, so let's place an image entity where we're going to place Arthur's present picture. We can use Medium, the account that we just had in the beginning, to get the profile of Arthur. Copy the image link and paste it on the image entity in Maltego. We also need the Lost Child's database. The database is in maltegocdf.org website, so you can download it using vget. Copy the database link and download it on the folder. We can now go back to Maltego and run the transform. After the transforms compares each image with Arthur's profile picture, it gets back with an image from the database. The transform recognizes Arnold Baer as the same person as Arthur. We can also see with our eye the person is the same as Arthur, and we can see the similarities. So submit Arnold as the lost flag of the challenge.
Congratulations, you have completed the course of Disinformation and Misinformation Dismantling. On behalf of the Department of State and Cyber Academy, thank you for trusting us with your time.